Hello, welcome back to part 3 of Logistic Regression in Python. So in the previous lesson, we've dealing with some missing data, right? And in this section, we're gonna dealing with categorical features. Okay, what do I mean by that? In this section, we're gonna talk about how to convert the categorical features into dummy variable format by using the library, the pandas library. So why do we have to do the conversion? Okay, if we take a look of the sex column here, we have the value male or female. But for machine learning algorithm, it is not able to just read the strings. Okay, these are the strings, to read the strings and understand that. So we have to convert this categorical feature, this column, to another form, another version, and that is called the dummy variable. Okay, and a similar thing here for embarked. Okay, so for embarked column, we have three letters, S, C, and Q. They represent the city's names, right? The machine learning algorithm also cannot just read these letters and understand that. So also we have to do the converting for this embarked column. So how can we do that? By using pandas library. So first, I call the pandas library, and the method is called get underscore dummies. Okay, and if you type shift and tab, you will be able to read the documentation here. What does the function basically did is just to convert the categorical variable into dummy variables, or sometimes we call that indicator variable. Okay, but in this case, I'm just gonna pass in the column that I want it to be converted. So it will be train sex. Okay. If I run this, you will see there it generates two columns, the female column and the male column. Both of them are with number 0 or 1. Okay, so for female column, if the value is 0, which means this was not a female. Okay, if it's 1, then this was a female. The same thing with male. Okay, but that might generate an issue. Okay, what's the issue? If I tell you the passenger is not a female, do you know the gender of the passenger? So obviously the passenger will be male, right? If I tell you the passenger is a female, okay, do you even need to take a look of the male column? We can do a perfect prediction by just looking at one column, right? So if we want to keep both of them, that might cause an issue. It's called multi-collinearity. Okay, so what I'm gonna do is I'm just gonna drop the first column off. To do that, it's called drop underscore first. Okay, and we set this argument, we set that to true. Okay, so what we got is we just drop the first column off and we keep one column, the male column. So we know if the passenger is male or not a male. Okay, but that is good enough. Okay, it's enough for us to know the gender of the passenger, right? And I will pass the whole thing to sex. Okay, the next one is with the embarked column. Okay, so my question is, okay, I want to know where the passenger from, which city the passenger from, and in total we got 3 cities, right? How many cities do you have to know in order to determine where the passenger is from? Okay, if I say I tell you, so the first column it might be C. All right, I say okay, let's just type that in. in this case, that is embarked. Okay. Okay. So if I tell you the passenger is not from C, not from Q, do you have to take a look of the S column here? Okay. You definitely know the passenger is from S, city S, right? But if I tell you the passenger, like, so the best case is I tell you, okay, if you take a look at the first column and I tell you, oh yeah, it is one, it is true, the person is in city C, then you don't even have to take a look of the rest of the columns. But the worst case is you only have to take a look of 2 columns and you can determine which city the passenger is from. So here, I'm also gonna drop one column. So we drop the first column. Okay. Now we have 2 city columns left, right? And I will pass that. I'll call that embark. Okay. So what we have is we have 2 separate data frames, right? And what I want is I want Adam to my original data frame, the train data frame. How can we do that? It is pretty similar with the string concatenation. Do you remember if you want to combine string 1 and string 2 together, the method you use is concat. Okay. The same thing here. So B train is equal to, because I want everything to be combined to my original data frame. In this case, will be train. Okay. So pandas library concat. Okay. So what should I put into my parentheses? So there will be a list of data frames that I want to combine together. So first one must be train, the second one sex, third one embark. Okay, combine them together, right? And don't forget to set the axis to 1 because that will indicate the columns, right? Okay, we can take a look. We can take a look of the train method, or the train data frame. Okay. Now we have what we have is we have all the original information, original columns left, and we have these the male column, the Q column, and S column added to the end of the data frame. Okay, that is good. These are the dummy variable format. Okay, so my machine learning algorithm can understand. Okay, so do I still have to keep the sex column and the embark column? No, you don't have to. These will be redundant, right? I already got the replacement, the substitution. Okay, so I'm gonna remove the sex column and embark column. Okay, so how about the rest of the features here? If you take a look of the name here, okay, does that really matter? Does that really matter to the survival of a passenger, and also the ticket number, the ticket code? Do they matter? Okay, so I don't think that's a good choice to pick these 2 columns as the features. Okay, if you want, you can do that, but I don't think that's a good pick. Okay, so what I'm gonna do is I will just drop all these 4 columns off: name, sex, ticket, and embarked. Okay, so let's do this. Train dot drop. Okay, how to drop a list of columns. Okay, as I said, it will be put in a list, right? It will be put in a list. Okay, so we type in the name, sex, and embarked, these two, okay, as I said, got replaced by mel, q, and s. And these two, oh sorry, name and the ticket, useless. Don't forget to set the access to 1. Why? Because that indicates that indicate the columns, right? 0 indicate the rows. And next one, in place, set that to true. Okay, you know what does that mean, right? I explained that several times. Okay. Now let's go back and take a look of our train data frame. Right, we got sex column dropped off, we got import dropped off, we got name and ticket dropped off. Okay. But now what we have left, the passenger ID. Okay, if you take a look of the passenger ID, what I see here is just from 1 to 1, 2, 3, 4. It more like an index number, right? It didn't give you that much information. To do that, I can also check the tail, right? It's just the index number. There's nothing much that we have to take a look at. So what I suggest is to remove the passenger ID as well. Okay, so let's drop the passenger ID. Okay. Now what we got the data frame is just we survived this P class, the age, number of siblings or spouse that is on board, parents or children on board, the fare, the ticket price, right? Is the passenger male or not, and also the Q and S column for the cities, right? Okay, but one thing here, I want you to take a look of the P class here, the passenger class here. Is that a categorical variable, okay, or is that a numerical variable? It's actually a categorical column, right? Meaning it can only have 3 distinct categories, 1, 2, or 3. And that means we could have also done the panda slavery and get the dummies on that column. Okay, I'm going to go ahead and leave that to you as an exercise. After you run the model within the normal column, you keep that as the categorical feature, right? And then also you run that with when you convert the passenger class to the dummy variables. Okay, you take a look, you go ahead and explore the difference between leaving it as a column by itself or converted that to the dummy variables. What's the difference between that? Okay, so all right, that is all for part 3, and so far we have dealt with the missing data and deal with categorical features. Now it's time for us to build a logistic regression model and to evaluate the performance of the model. So see you in part 4.